Alright, I've been telling people this is the fifth part of the lecture. I think this is just the fourth part of the lecture, but it's the final part of this lecture. Now, putting this together, based on all this information that we are gathering from these high-quality observations collected under very controlled circumstances all around the world, what do we actually know about climate change according to the IPCC Fifth Assessment Report? Well, based on remember, all they do is collect information from other sources. They review the literature, and they use that information to advise governments and so on. Well, there's various data sets that are used to monitor the global mean surface temperature and so on. You can see 4 of them happen to be on this particular chart for land-based observations, and oh my, it does not look good, right? There's quite a temperature trend going on there. And in fact, if you do the same sort of thing for the ocean, on this diagram here, well, there's certainly more discrepancies between different databases. They are having less agreement, especially prior to about 1950. But certainly since 1950 to the present time, I don't like that trend at all. I mean, clearly the temperature is increasing quite a bit. Now, this is air temperature above the ocean. We will get later to, like, when we talk about oceanography and stuff like that, we're going to be talking, but this is air temperature over the ocean, things like buoys and merchant ships and so on. And we have a very clear example of a trend since about 1950 or so. In fact, now this diagram is a little hard to read, but it's horrible once you understand it. Each of those little pairs of boxes there represents, the white line is like the average temperature globally, and the gray boxes indicate like kind of like a box and whiskers diagram that showed the error. It's the 90% confidence range. The true global temperature for each of those decades is somewhere inside those gray boxes. And so the 1850s is down there at the bottom, and then the 1860s, and then the 1870s, all the way up to the first decade of the 2000s. And once you know the format of the diagram, aren't those top 3 boxes there terrifying? The 1980s were warmer than any decade before them. In fact, they didn't even overlap in their 90th percentile confidence range with any decade before them. And then the 90s came along and were warmer than the 80s, and their 90th percentile range is not overlapping. There's no room for uncertainty there. And then the 2000s came along, and they're the warmest decade, and their 90th percentile doesn't overlap the 90th percentile of any other decade. That is really, really bad news. It is clear, it is strong evidence that the planet is warming. Let's see here. So again, here's another archive of the same sort of thing. I can't remember here. Global mean surface temperature anomalies relative to their climatology for the land surface and the sea surface temperature databases. Okay, again, we see this temperature change here. And in fact, all these diagrams that we've been seeing so far is a global mean temperature, but we could switch on the next slide to actually look at like individual locations. So there they divided the world up into what are these, probably 5 degree by 5 degree boxes or something like that, and a few places they weren't enough data observations for them to do this kind of analysis, but over almost the entire world, let's see, a positive temperature trend over at the 112-year period. Let's see, anything in oranges or purples is a positive temperature trend. Oh my, that's pretty much the whole map, except for a little area of cooling off in the North Atlantic that's probably associated with melting of water off of Greenland, where cold water is coming off of the ice sheets on Greenland. Oh my. So pretty much every place on this map has a statistically significant temperature change. Statistically significant locations where the temperature change is statistically significant are indicated with those little plus symbols on there. Statistically significant. Has to do with how we test hypotheses. We can prove with great confidence that this temperature trend is not zero. We'll learn more about testing hypotheses later in the semester. Oh my, this does not look good. Looks like pretty much the whole world is warming. The northern regions are certainly warming a lot. Oh my, this is just not good at all. Here's another textbook here. This is based just on in situ observations. And you can see the temperature trend over there. Clearly there has been a warming since the early 1900s in this data archive. And you take a look at that, the most recent decade was clearly the warmest decade on record and so on, and it's just not good. In fact, if you pull up the annual values that plot was based on, what you see is that 9 of the 10 warmest years on record occurred since the year 2000. And this one doesn't even have that scary 2015 in there, and 2016 is even worse than 2015. Oh man, this is not looking good. These are high-quality observations being processed under very controlled circumstances, and we're seeing a trend that we are not liking very much. These trends are huge, too. I mean, if we tried to fit a line through this over the last 100 years or something like that, just to like throw out the Dessler textbook as an example, we're not using the Dessler textbook this semester. Dessler says that the rate of change over the last 50 years works out to about 1.3 degrees Celsius per century. That's about 2.3 degrees Fahrenheit per century. That's a pretty big temperature change. We're going to have to learn what the significance of that temperature change is and so on. Other textbooks measure it, using different instruments or different networks or different techniques and come up with slightly different numbers, more like nearly 1.2 degrees Fahrenheit per century. I mean, that's a smaller temperature change during a different time period. I don't really love terms like degrees Celsius per century. I mean, that's kind of useful to help us remember, but keep in mind most of the time we're going to want to change this to something like degrees Celsius per year, where we're going to have divided by 100. So it's a relatively small amount of warming each year, but over the course of a century it really adds up. Some textbooks make a big deal. There's some paragraphs in the IPCC report that talk about the fact that the warming seems to have happened in two main periods. There seems to be a period between about 1910 and 1945 where the world warmed up quite a bit, and then the world sort of maintained that temperature from about 1945 to about 1976, and then from 1976 on, the in situ temperature observations say that we have been warming at a relatively fast rate. The warming is not very uniform. We find that if we examine just different large regions of the world, so we've been seeing that top panel before, now we're looking at this bottom panel from a different textbook. The solid line is the temperatures averaged over the world from 24 degrees north to the pole. I don't know why 24. Basically, we're talking outside of the tropics to the pole at the northern hemisphere. Oh my goodness, look how much the northern regions have warmed up since about 1980. Holy smokes, look at all that warming that's happening at the northern regions. It's true that the tropical regions, which are sort of the dotted line, or the southern polar regions, which are the dashed line, they are both also warming, but nowhere near as much as the northern polar regions. In fact, if you examine the temperature trend in that second period of warming from 1950 to roughly the present, you can see that most of that temperature trend warming has been at high northern latitudes. We're going to learn more about like ice albedo feedbacks and so on later in the semester as a mechanism for explaining this, but you can see that polar regions in the northern hemisphere are the primary place where warming is happening. And I want to draw your attention, okay, remember globally the planet was warming at a rate of about 0.7 degrees Celsius per century. Take a look at the scale on this diagram. That scale is in degrees Celsius per decade. And we've got numbers like 0.5 on there. So 0.5 degrees Celsius per decade, that works out to 5 degrees Celsius per century. And plenty of areas up in the northern region of the map have about that much warming. My goodness, northern Alaska, northern Canada, Siberia are having a lot of warming. Pretty much everything I've shown you so far has been for in situ temperature observations. For what it's worth, the temperature observations from satellites are very consistent with that. Satellites are completely independent of the in situ observations, and therefore they provide very strong evidence or strong confirmation of that warming trend. If the satellites were telling us something different than the surface observations, we'd be worried about that. But they don't. They are in very good agreement about the trends and so on. Well, it is the job of the IPCC to make sense of all of this and provide context and guidance about this information to governments and so on. That's why they write relatively boring reports like the AR5. What did they actually say about that? Well, if we go into chapter 2 and start reading about temperature, they say it is certain that global mean surface temperature has increased since the late 19th century. Certain is a word you don't see in scientific literature very much. In the IPCC reports, they provide guidance as to their measures of uncertainty. They talk about things like likely, or most likely, or probable, and they have actual definitions of what those chances mean. One of their thresholds is virtually certain. Virtually certain means that they are 99 to 100% sure that this is true. Certain is above virtually certain. They are saying it is 100% definitely the case, based on the scientific observations, that the global mean surface temperature is increasing. There's no question about it. That crazy uncle on Facebook who says it's all a hoax, he's wrong. Okay? It's okay to have different opinions about certain things. It's not okay to not share facts. And the facts are the planet is warming. Excuse me. Notice they actually provide error bars on their estimates. In their case, the globally combined land and sea surface temperature, as calculated by a linear trend, shows a warming of about 0.85 degrees Celsius over that period there. Again, using a different technique and so on. And notice they're actually providing the error bars. It's in that range. Notice another thing they say in that chapter. It is unlikely that any uncorrected urban heat island effect or land use changes effects have raised the estimated temperature by more than 10% of the report. This is a complicated sentence to parse, but it's so important. An objection that certain skeptics provide is that maybe the temperature changes that we're observing is just about urbanization. The weather station used to be more out in the country. The city grew out over the weather station. We know cities are warmer than the countryside, so of course the temperature went up. But of course we also correct for that. And what they're saying here is that it is unlikely, that is less than 33% chance, that there are uncorrected urban heat island effects that are accounting for more than 10% of the trend. Think about that. So they're saying it's not even like, there's not even a chance that it's 10% of this trend that we're talking about is being associated with just the urbanization. This objection that certain skeptics raise is nonsense when you examine the facts. It is very likely that the numbers of cold days and nights have decreased and the numbers of warm days and nights have increased globally since about 1950. Very likely is their jargon. Again, you can go into their table where they explain all of that stuff, and you see that very likely means that there is a 90 to 100% chance that this is correct. It is very likely that the number of cold days has decreased and the number of warm days has increased since about 1950. Then they talk more that there's only medium confidence that the length and the frequency of warm spells, including heat waves, has increased. Those things are harder to prove. That's what we talked about in the last lecture. It's harder to prove trends in things like the frequency of heat waves or other kinds of extreme weather events. Confidence is low that global scale observed trend in drought or dryness since the middle of the 20th century owing to lack of direct observations, geographical inconsistencies in the trends, and so on. What they're saying here is there isn't evidence that droughts are becoming more common or that they're becoming more extreme. Don't get me wrong, there are droughts. There are droughts that are very extreme, but the evidence that they are related to global warming and anthropogenic change and so on doesn't exist yet. Confidence is low that that is true. Finally, one more thing that everybody wants to know about, is there a connection between this and hurricanes? Well, confidence remains low that there's a long-term changes in tropical cyclone activity after accounting for past observing capabilities. In other words, as we changed how we observe hurricanes, like we added satellite data and so on, it becomes difficult to sort out if there's an actual increase in the number of hurricanes and so on. So confidence is low in that kind of result. All right. In the next lecture, we're going to continue covering some of the evidence that we take from observing systems about global change and so on. But let's wrap up this lecture with 3 more quick questions. Question 10. Approximately how much has the surface of the Earth warmed in the last century? Excuse me. And you see the 4 numbers right there. This again is an actual question that I asked on an exam a couple semesters ago, so I'm not sure I'll ask this question again, but it gives you a sense of the level of difficulty of some of the multiple choice questions on the test. Make a choice from those 4 options and get a little feedback before we move on to question 11.